Sketching the graphs of sec theta, cosec theta and cot theta. Remember in a previous video that we've just introduced three new trigonometric ratios, which was sec theta, cosec theta and cot theta. Remember that sec theta is equal to 1 divided by cos theta, cosec theta is equal to 1 divided by sin theta, and cot theta is equal to 1 divided by tan of theta. Now, if we draw the graph of y equals sine x in this case, and we look at our graph, we know that from core 2 that it looks like this, between minus 2 pi and 2 pi. We know that it starts at 0, rises up to 1 when pi is 90, returns to 0 for pi, and then goes down into negative to minus 1 and back up to 2 pi. And it oscillates like that continually for however long you want to draw the graph. Now, cosec theta is equal to 1 divided by sine of theta. So if you look at 90 degrees, if you type into your calculator 90 degrees or pi over 2 in this case, 1 divided by sine of pi over 2, you should find that you still get the answer 1, because sine of pi over 2 is 1, so 1 divided by 1 is 1. However, if you do, let's say 45 degrees, which is pi over 4, so 1 divided by sine of pi over 4, you get the answer 1.414. So it starts to rise back up again, like this. And it does likewise if we tried 3 times pi divided by 4. Now, what happens though, because when sine is 0, it doesn't show on the graph where it goes to. Now, if you try on your calculator 1 divided by sine of 0, you'll find you get the answer mathematical error. Because what is sine of 0? Well, sine of 0 is 0. And what is 1 divided by 0? Well, we don't know the answer to that, but what we do know is it's getting closer and closer and closer to infinity. So 1 divided by 0 is infinity. Now, we could also do the same when looking at the values for 3 pi divided by 2. It should be touching there and there. There's obviously a slight gap when this has been produced. Now, if we did sine of 3 pi divided by 2, we get it as minus 1. And 1 divided by minus 1 would be minus 1. But then if we took values either side of it, we'd see the minus numbers are beginning to get bigger and bigger and bigger, until eventually we start to get to the same problem that we had with 0. What is sine of 2 pi? Well, that's 0, and 1 divided by 0 is infinity. So as you can see, the graph of cosec of theta is flipping, where you've got minus pi, it goes from up here right down to here, so it's flipping from one to the other. Okay, now that is very similar to what you get when you draw the graph of cos of x, but as we know before, cos of x is just the sine graph shifted to the left. And likewise, the same thing happens with the sec x. That also shifts 90 degrees to the right. So the two are very similar. So if you look here on the cosec theta, that's between 0 and pi. Well, on the graph of sec theta, it's between minus pi over 2 and pi over 2, which is 90 degrees. So it's 90 degrees shift to the left. If you have a look at the graph of cot theta, which is here between minus 2 pi and 2 pi, we've got in red the tan x, which goes like that, and cot of x is in the opposite direction. And as you can see, at pi over 2, so 90 degrees, it is equal to 0. And now this is something that we're not used to, because if you type into your calculator tan of pi over 2, you get mathematical error. So you're asked to do 1 divided by tan of pi over 2. Well, remember that we assume that tan of pi over 2 is equal to a value that is very close to infinity, because the tan graph continues to rise until it gets to infinity, because you can't find the angle of tan of pi over 2. But if we assume that to be infinity, well, we're taking a 1 and we're splitting it into infinite parts, so the answer is almost going to be 0, so we put it that it goes through 0. Now you can see that this graph oscillates the cosecs every 180 degrees or every pi radians. Now you could be asked in the exam to sketch various graphs to do with cosec, sec and cot under various graph transformations. So this one, it says sketch a graph of y equals minus sec theta between minus 180 degrees and 180 degrees. So we need to draw ourselves a quick sketch for the axes y and x. So we've got minus 180, let's have minus 90, 0, 90 and 180 degrees. So remember, if we look at our graph we've done earlier on for sec theta, we can see that between minus 90 degrees and 90 degrees, we're highlighted here as minus 2 pi and pi over 2, sorry, minus pi over 2 and pi over 2, we can see that it goes from 1 upwards. Well, if we're doing minus sec x, it's going to go from minus 1 downwards. So back to what we've been asked to do. So between minus 90 and 90 is going to be going downwards. The maximum point is going to be at minus 1. So that means between 90 and 180 degrees it's going to be going down towards 1. And between minus 90 and minus 180 is also going to be going down towards 1. Oops. Let's get my rubber, which I won't be able to do now. So it's going to be that part there. Next thing, we're asked to do y equals 2 cosec theta. So this means that we really only need to look at our maximum and our minimum values on our cosec theta graph. Well, the minimum value here is 1, but it's going to, because we're doubling it, it's going to be 2. Likewise, if we've got minus 1, we're going to be doubling it, it's going to be minus 1. Now we're asked to draw this graph between minus pi and pi. So first thing to do is to draw yourself a quick axis between minus pi over 2, 0, pi over 2 and pi. So at 90 degrees or pi over 2, we know that cosec of pi over 2 is 1, because 1 divided by sine of pi over 2 is equal to 1, but we're doubling that, so it's going to be 2. And it's not going to be able to touch the 0 axis, but it's going to look something like that. Likewise, if we were to take 1 divided by sine of minus pi over 2, it would give us minus 1, and we're doubling that, so it would be minus 2. So we're going to form a shape something like that. And that is a a sketch of y equals 2 cosec theta. Final one we need to do is we want to sketch the graph of y equals cosec in brackets theta plus pi over 2 between 0 theta and 2 pi theta. So yet again, first thing we want to do is we want to set out our axes between 0, pi over 2, pi, 3 pi over 2 and 2 pi. And if we remember that this means that if it's plus pi over 2, it means that our original cosec theta graph is going to be shifted by 90 degrees to the left. So remember, cosec is 1 divided by sine of theta. Well, 1 divided by sine of pi over 2 is going to be 1. But remember, we're looking at that being shifted by pi over 2 to the left. So instead of now 1 being where pi over 2 is, it's going to be shifted to the left by pi over 2. So it's going to happen at 0 now. So 0 radians is going to be equivalent to 1. That means it's going to rise to pi over 2. This now means that, remember, that 3 pi over 2, the cosec of it is minus 1. Well, that's being shifted pi over 2 to the left, so now minus 1 is going to be where pi is. And the remaining bit of the graph will be here, going up to there, because the next, if we add pi over 2 to 2 pi, we have 5 over 2 pi, and if we did 1 divided by sine of 5 over 2 pi, we get 1, so that's going to be shifted pi over 2 to the left, which means that 2 pi we're going to be equal to 1. So the 3 new trigonometric ratios have graphs as shown. So y equals cosec of theta is between 0 and 2 pi. The graph of sec theta between 0 and 2 pi, and the graph of cot theta between 0 and pi.